All right, howdy y'all, and welcome to our September users group. Today we'll be going over what's new with FactoryTalk View uh, Enterprise and version 13 and guidelines over HMI displays. If any of you have missed any of our previous talks this year, you can find them on our company YouTube channel, as well as through the training and events section of our website, reynoldsonline.com. We have a few other topics coming up this year, including an overview of the Rockwell certificate program and a preview of what you might expect to see at Rockwell Automation Fair in Chicago this year, which will also have portions of the event live streamed for those that can't attend in person, like the keynotes and some of the other presentations. Also on our website, you'll find various blog posts, podcast news, and other videos that we've created over the years, especially since the 2020 timeframe. If you're just browsing around, make sure to check out both the resources section and the training and events section in the top right of the image shown. That will typically get you to most of the content that we've created and provided on our website. Today, my name is Brian Mikeska. I'm an automation specialist for the Reynolds Company. Alongside with me today is my counterpart, David Nute, and in the background, Wayne Welk, who might be fielding any questions in the chat or the Q&A if anybody has any. Speaking of Automation Fair, I mentioned it earlier. The dates this year are November 16th and 17th in Chicago, Illinois. Registration is now open, and lab and session signup should be expected to open within the next week. Automation Fair itself is free to attend for customers. You have to get your way there, typically. We do have hotel packages available through the Reynolds Company for their 1 night or 2 night stay. And it includes a ticket to our hospitality event at Pinstripe. So those that went to previous automation fairs in Chicago, it'll be the same venue. 2 days prior to Automation Fair, November 14th and 15th, is the Process Solution Users Group, also known as PSUG. This event does incur costs, and right now the early bird special, I believe, is $3.99, which will end on October 1st. And after that, the tickets will increase to around $600. PSUG focuses on the latest releases of Plant PX Batch and other supporting process solutions with additional keynotes, hands-on labs, technical sessions, open discussion forums, and there will be a networking event on Monday evening. If you have questions about any of these 2 events, please reach out to your local account manager or specialist if you don't know your account manager for additional information on either PSUG or Automation Fair in Chicago. Now to go over some of the newer quirks and features that you'll see with FactoryTalk View. There's been a consolidation of catalog numbers where the majority of projects will now have a unlimited display bundle in either the station standalone runtime or the distributed server runtime with clients. Furthermore, with the bundles, the pricing has become a bit more competitive in the marketplace, both in upfront costs as well as support costs. Historically, you were dinged with the bundles for the clients, even though you may not be using the majority of the clients in that bundle. It seems that that's been corrected for the most part to more align with what we're seeing in the industry in terms of ongoing cost for maintenance and support. For the version 13 release, FactoryTalk Viewpoint web client is no longer available as an add-on because it is now available and unlimited in the base version of either station or the server variants, the server bundles. If it's natively included in version 13, but if you aren't quite ready to make that jump yet, version 11 and 12 also have FactoryTalk Viewpoint unlocked for unlimited clients, but there is a patch to do so. So if you're on version 11 and 12 and would like to give it a go, there's a Rockwell knowledge base document under BF27866. You can also just search the knowledge base for it, and it will allow you to have those unlimited number of clients. Additional connectivity improvements have also been made, including with OPC UA and other FactoryTalk softwares. Additional expansion on these scripting capabilities with PowerShell that were released in version 12 has also been improved, as well as the inclusion of new objects to speed up and standardize development of displays. So here's a quick feature summary of some of the improvements that we'll cover in the upcoming slides. Version 13 is looking to be a really nice quality of life improvement to the development cycle with the additions that you see on this page, as well as simplifying the ordering process. As I mentioned earlier, by taking the number of available catalogs from 19 down to 8 catalogs for ordering. So pretty much it's kind of a consolidation and simplification across the board, as well as an expansion on the capabilities of the software itself. Here are the 8 options that I talked about and how it's kind of been consolidated. You'll notice the majority now have an unlimited display count with the exception of station light. For most projects that we see come across, our customers and SIs are likely going to be picking the unlimited display variants. So with a standalone or a server system, previously the bundles were in the 10 and 25 client bundles. We've now added a 5 client bundle to help be a little bit cheaper, as well as go for those smaller systems where 10 clients was an overkill, but it was unfortunately like the best cost solution back then. And as I mentioned, the costs have been kind of reconfigured, brought down a little bit to better compete with some of our competitors. You can still add clients a la carte later on if you need, or you can still choose to stack the license if it makes sense cost-wise, as you could before, to obtain the configuration you need for your specific installation. Rockwell's commitment to bringing FactoryTalk View capabilities to mobile devices in the field to improve the usability, visibility, and actionability of an operator's, engineer, and manager's tablet or phone device. Using these combined with items like geofencing or something like a Bluetooth beaconing or NFC badged access, you can provide a safe way to implement mobile HMIs throughout your facility, as well as providing view-only access for on-the-go information needs for somebody like an engineer, manager, or an operator that are going to a meeting and maybe doesn't have eyes on the equipment, but just needs to see what's going on and relay what's going on at that moment in time. Each new release of FactoryTalk View has seen better integration both with other Rockwell hardware and software, as well as third-party software. One to point out at the bottom of the page is SciTech's Excel Reporter, which has also had a better integration with the latest FactoryTalk Links Gateway release. With PlantPX 5.0 and 5.1, along with FactoryTalk Security and Asset Center, audit paths for individual users can also be used to determine the who, what, when, where. of a certain event, action, or series of events for traceability and regulatory compliance. The latest logic controllers also have feature sets which have been integrated for use to display, better inform, and take more meaningful action on those events within the process space. Pre-built options for items such as alarm objects and process objects help contribute to the idea of no code or low code, where an individual without hugely extensive knowledge or experience with the system can start developing quickly with pre-built templates. The pre-built alarm objects can pretty much slap into the HMI with no configuration up front, but there is customizability for all the various columns, colors, filters, etc. You'll start likely seeing no code or low code start kind of popping up more often in the Rockwell presentations. The idea is to really, like I said, allow someone without a huge, extensive knowledge to get up to speed more quickly and be able to assist and help out in the fastest possible time. Even more information is now available within Trend Pro and is provided by alarms and events, allowing for more context or greater context around an interested point in time. Providing operators with a full picture of what's happening in a plant can help speed up troubleshooting, response time, making an accurate response, and providing detailed information about what to look for the next time an event or series of events might be starting to occur, to get ahead of anything that might lead to and cause downtime for something that's been seen before. Having clearly marked data can help with that efficiency and decision making for all personnel. And this is just one more way to kind of add to that cookie crumb or the breadcrumb capability of finding out what's actually going on and determining what's actually going on in a environment. Additional libraries have been added for newer catalog numbers like the upcoming, or I think it's here, the 755T, the Stratix 5800, the L8 controllers with the 5580 control logics, the 5380 compact logics 5000, Flex 5000, all the new IO link devices, and much more that you see on this list here. These all help contribute to that low code idea or no code idea to assist in speeding up that development cycle, as well as having a more standardized approach for more than the single individual that's starting to develop the screens. They can get up to speed much faster, or if you have multiple people developing the screens, it's easier to understand, troubleshoot, and update a series of displays between multiple individuals because they're using the same design process and design libraries throughout. And so some improvements on version 13. Excuse me, I'm going to take a sip real quick. A version 13 expansion on a release capability introduced in version 12 is the ability to have the bidirectional information with the use of PowerShell scripts. So previously it was only, I believe it was only one direction. Now you can go both directions, to and from the script to the HMI. You can introduce custom application code that can trigger on events, such as tag value within FactoryTalk View SE, or within the FactoryTalk View SE server OS, System events can trigger a script to delete, create, read, or write HMI tag values without needing the FactoryTalk View SE client. Previously with VBA, the code needed to rely on a single client to execute the code, while this implementation allows the coding interface to execute directly on the server instead, with PowerShell, with direct access to the HMI tags themselves. Other features of using a PowerShell script is the ability to send emails and update text files or logs. An example of this, let's say you have a process that reached a point where it has to perform a recipe deployment, but the recipes are in an external database somewhere. When a process reaches a point where it needs the tags for those specific recipe or recipes, the code runs on the server, or the script runs on the server, creates the HMI tags for the recipe set points. It queries and loads the values from that database and the external database. All of this would be a server-side action from the PowerShell script, without the need for a FactoryTalk View client. When the script completes, it'll let the HMI know that the next steps can be taken via the created or existing HMI tag value that can be monitored from the HMI itself. From there, the HMI tags that were dynamically created can also be used and displayed within the HMI. And when the recipe is completed successfully, another PowerShell script can trigger to delete the appropriate HMI tags that you no longer need, and helps declutter, I guess, anything that was created at that time. Another improvement, .NET has always kind of been in the background of the FactoryTalk platform as a whole. Now there's graphic object support to have better looking pre-configured graphics for custom recipe allocations. This is currently based on .NET 4.8 and earlier. It will not work with controls relying on .NET Core, .NET 5.0 or .NET 6.0 at this time. So do make sure if you're going to look at this that any controls and control objects you use are 4.8 and earlier. Third-party libraries can be added to, again, it's all about speeding up and making the development process a more cohesive exercise by standardizing all the objects being used by one or more individuals that are designing screens. Another neat little feature that's been added with the latest FactoryTalk Services platform download available on the Rockwell Product Compatibility and Download Center, commonly referred to as PCDC. You can choose the option to install the FactoryTalk System Status Portal, which gives you insight into all of the servers running in a single environment and their respective status. This can be a pretty useful tool for somebody like a system integrator who might be going through a checkout process, or even during acceptance tests to view the status while forcing failovers during testing and verifying that the forced fail has actually successfully completed and the switchover is successfully completed if you're just using redundant servers. This can also be viewed within the FactoryTalk View application itself for a quick high-level overview of the system status. The integration of FactoryTalk links has been simplified for use with FactoryTalk View SE and other third-party devices. OPC-UA uses the publish-subscribe model, where a device only receives information that is needed and of interest to those that are subscribing to those the needed information. Another efficiency improvement for this, using the connector, you can eliminate the need to duplicate alarms across differential environments that may be from two different vendors. So you're reducing the amount of overhead work that needs to be performed, and restricting the amount of duplication that's necessary to make unlike environments talk together and work well. The licensing for Thin Manager is now integrated with FactoryTalk View, or with a FactoryTalk Activation Manager and its environment, and for hosting, rehosting, binding to the license server in the same method and manner that you're used to with other software under the Rockwell umbrella. This isn't necessarily new, but if it's been a while since you've ordered Thin Manager, this will be something that you definitely notice when you go to activate the software. You'll end up going to FactoryTalk Activation Manager instead of the older traditional Thin Manager way. Thin Manager also now allows for authentication pass-through. So in the past, users had to log in with Thin Manager and other software applications separately. So you had to do the multiple login if you're a user, but now the single user can log in once for multiple supported HMI products such as FactoryTalk View SE, thus streamlining the login process. And the version 13 on this is actually Thin Manager version 13. So you'll notice that Rockwell will start aligning, or is trying to align certain versions with one another. And this is one of those instances where Thin Manager version 13 is starting to align with FactoryTalk View SE version 13. And Thin Manager itself also now has an event-based content delivery to display relevant visualizations based on a trigger from another application or event. Previously, the visualizations within a Thin client running Thin Manager were served up and displayed based on the device being used, the individual Thin client or mobile tablet phone. The user that is signed in via the Active Directory or configured roles, or by the physical location using GPS, Bluetooth beaconing, or other geofencing methods. Now with the event-based delivery, immediate important information can be displayed or forced to pop up as it occurs in real time. So an example of this would be if a security or safety area were determined to be breached by sensors and other devices, and there was a camera nearby, overlooking that area, that camera feed could instantly be popped up in a desired size, location, and window. So it doesn't have to be just an instant full screen. It can be a subset of that, of how you break it up within Thin Manager, to let the operator, engineer, manager know instantly, that there may be an issue and something's going on, and something may need to be taken care of at an immediate moment in time. You can add components to a running application using a command line tool called FactoryTalk View SE. You could do this with previous versions, but it wasn't as well known as a tool. So FactoryTalk, to use this tool, FactoryTalk View Studio Enterprise must be installed on the computer where the commands are being run. The component file can't have a hidden file attribute set. So make sure that you can see it with, all normal levels of access, and be careful when naming the component files with special characters, as some special characters are not allowed in the component name or the component file name, which is pretty standard with some of the Studio 5000 FactoryTalk View platform regarding special characters. When you do run it, You'll get a log file um, that will be generated describing the results of the execution. And the command line itself will return a 0 for success or a 1 if the execution errored unexpectedly while it is trying to add the components into a live running system. You can also use this tool for FactoryTalk alarm and event configurations and live changes. The knowledge base to find these tools, again, you can go and search the knowledge base for them. It's QA60431. And there are separate tools available for version 12 and version 13, so make sure to download the respective version that matches what version of FactoryTalk VUSE that you're running. And this tool itself is a direct result of customer feedback. So if you've ever given feedback to anybody at Rockwell, please continue to do so. They are listening. And this is one of the tools that has come out of that level of feedback. I mentioned earlier about being able to use the latest feature set of the L8 controllers, the Compact Logix 5380 and the Control Logix 5580. This includes tag-based alarms, which means you no longer need to maintain a separate HMI database. You can access and display tag properties created in the controller directly from within the HMI itself. There's also a property checkbox that allows an alarm to be suppressed in a way that will not be evaluated or show up within an alarm object. This can be useful on the development side of testing within, let's say you're using a template or a kind of a go-to where you might not be using all of the items from within that particular template or go-by. You can easily just have a checkbox to essentially permanently disabled so you can test everything else without causing further issues. And with that, I believe I'll hand it over to David for the remainder of the presentation.
Okay. Thanks, Brian. And so I'm going to go ahead and request control here. And so I'm going to switch gears slightly and talk about situational awareness and how it affects HMI systems. So when we think about situational awareness or situation awareness, what comes to mind for me in our everyday lives, for example, would be, driving, and specifically driving through school zones. Say school just started a few weeks ago, and whether you have kids or not, whether you drop kids off at school or not, is not the point. But the point is, we know as drivers, when we go through a school zone, first of all, we're alerted by it. So usually we see signs, hopefully there will be flashing yellow lights. The speed limit is reduced when we're in the school zone time period. And so those are all important because those lights and those signs and everything make us aware that the school is close, but more importantly, that we need to keep a diligent watch for increase in pedestrian traffic, kids running around, maybe bicyclists, buses to be aware of. And so driving through a school zone would typically be what I would call a kind of an abnormal or not normal condition of driving. And so as we move into the HMI system, I think it might be delayed a little bit. Let's see if I can get it to move. Sorry about that. I should have control. There it goes. Sorry. So when we think about HMI systems and think about the value of HMI systems, yes, we can see the visualization piece. We can see data, but what really comes down to a value of an HMI system is how does the HMI system help operators respond to abnormal conditions? Because the abnormal condition is something that needs to grab the operator's attention for immediate action, well, whatever that action may be. So that could be an alarm, that could be a process drifting out, maybe before it goes out into an alarm situation, and try to address that before that happens. Lots of different situations. And so the problem over the years with HMI systems, as HMI functionality increased and the graphics engines and the capabilities of HMIs increased, was the design of the HMI did not really take into account situation awareness and how do we handle abnormal conditions. And so if you look at the screen here as an example of a nice looking screen, you see 3D pipes and you see 3D vessels and lots of colors, lots of maybe blinking lights or things that are moving that grab our attention. But the problem is those don't help us when we try to respond to abnormal conditions. So over the years, our HMI screens, we've put too much data on them. We didn't handle our alarming well. We added animation links. We added moving links. How many HMIs have you seen with trucks that go back and forth or rail cars when we load or unload rail cars on systems? All those kinds of things that our HMI systems are capable of, and we've added that capability into our systems, doesn't really help us improve our situation awareness. And so that's the problem. And so specifically, these busy screens are pulling our attention away from actually potential problems that are actually in the manufacturing facility that need to be addressed through the HMI. So, and a couple more slides here. I want to go through an exercise with you just to kind of prove this out a little bit. And so imagine, as I go to the next slide, imagine the alarm condition. You see all the numbers here on the screen. Imagine the number 5 is an alarm condition. And so with everything jumbled together, everything's one color here, but imagine finding the 5s in all this mess. Well, yeah, you can find them, but it's going to take you more time than it should. And you're losing valuable time in the process that needs to be fixed. So what if we made the alarm conditions one color and kept everything else the same? Wow, all of a sudden the 5s just jump out on the screen for you. So that's an example of helping you respond to an abnormal situation. If the 5s were alarms per se, all of a sudden they jumped off the screen, and now I know where to look. My eyes went directly to all those 5s, and then I can address the problem. So let's swing on to the other side of the pendulum, and let's say we have 5 or 6 or 7 other colors to the HMI. Now all of a sudden, yeah, the HMI, the alarms are there, but all of a sudden the blues and the reds and the yellows also grab my attention, and so it becomes harder again to find the abnormal condition. And that's where we don't want to be. So what we really want to do with HMIs going forward is we want to improve our situation awareness. And this is an example here of the same process. On the left side, we see the old design with all the pretty graphics. There's a lot of data on that side. There's numbers and there's visualization things to look at, but there's not as much useful information. And so when I look on the right-hand side, yeah, it's gray and it's sort of drab, but my eyes are directed precisely to where I need to be, where my alarm conditions are at. So I know I've got an alarm because on the top of the screen, I've got a red circle and a red rectangle. And then when I look in the middle of the screen, in the middle tank there, I can see I'm in an alarm condition right away. I don't, my abnormal condition is staring me in the face basically. And so asking me to take care of it. So that's where we want to end up with situation awareness, is we want to be able to provide useful information on the screen and not make it so busy. And so that it becomes, even though the data is on the screen, it may not be as useful to us. So how do we do that? So that's one piece. So the other piece is how do we organize an HMI system? Because we obviously have to have multiple screens. We have many screens. We're typically controlling complex processes or manufacturing facilities. So we want to be able to, number one, we want to be able to provide a good overview to the operator of this entire system, with the ability to go down to a very granular level and troubleshoot. And all that needs to happen in one system. So how do we do that? Well, this is kind of a general diagram or architecture of what to follow. And so what we have here is really 4 different levels of screens, of displays. What we call a level 1 display, it would be an overview screen of the entire scope of what the operator is responsible for. So that could be, if it's a small facility, that could be an entire manufacturing facility or process facility. Or if it's a larger facility, that may just be the particular unit that operator is responsible for. But it is an all-encompassing high-level overview. And typically that could be just one screen on a system. Typically that's how Rockwell looks at it. But then that screen, if you do have a large TV screen or monitor in the operator room, control room, that screen may be on a TV. If you don't have that, maybe there's a way you can do multi-monitors for the operator, but always have that level 1 screen available to look at the overall system. But the level 2 screens would be typically where the operator primary time, most of his time is taken. So that would be in a normal operation. So the level 2 screen will show to be able to look at all the normal operations. Maybe if there's some routine set points that need to be changed or steps that need to be acknowledged, you could do that from the level 2 screen and still have a pretty wide view of what's happening at the facility. And so then we get to the deeper levels. We're getting into the more of what the HMI value is really about. So we get into level 3 screens, or typically be a non-routine operation. It could be a unit or a piece of equipment that may need to be diagnosed a little bit. Maybe there's some drifting in the temperature, and it's about to go out of set point range, and so you need to get a little more information about that particular piece of equipment. So then you would go out into a level 3 screen, which is still a full size screen on your HMI, but it does give you a little bit more deeper information. It might give you some typical normal operating conditions that you'll be able to view your alarm criteria from level 3, but you're looking a little deeper into your system. And then finally, the level 4 screens are where we get into the details of a particular piece of equipment, whether that's a pump or a valve or something very granular. So at level 4, typically those are pop-up screens. So we'd be looking at face plates, whether that's for a motor or a PID loop or a temperature transmitter. So we might be looking at interlocks, any diagnostics, We may actually also want to embed some further information, whether that's some sort of documentation or information for the operator. And that would be in the faceplates or the pop-ups. So this kind of encompasses the design of a multi-level, multi-view HMI system of the future. So with respect to navigation through these 4 levels, there's some kind of guidelines to follow. So, obvious first important task is it must be quick. So you don't want to have to hunt and peck, down an explorer tree menu of different displays. You want to be able to have simple point and click buttons, or be able to point and click on the screen to get to your level 3 and level 4 screen from level 2. And again, it must be logical. So it must follow the process or follow the manufacturing facility. So it's chronological or spatial type of screens. And consistency is important. So the operator needs to know that where his level 2 and level 3 screen access is going to be wherever he is in the system. And for alarming, the operator also needs to know where that alarm banner is going to be everywhere throughout the system. And a lot of this is pretty simple, but it's important. And then through ISA, ISA has done a lot of research in this and come out with standards we'll talk about. But ISA recommends a maximum of 4 levels of HMI screen, and that includes your faceplate. And so those of you that have used Rockwell faceplates know that those faceplates are very detailed and have different tabs, but that is as deep as we get. We don't go deeper than 4 levels on an HMI system. Okay, so a little bit about what the product offers, and this is Plant PAX templates, but these are also available with any FactoryTalk View SE system. The Plant PAX templates. We just for our purposes today, we're sort of using Plant PAX and FactoryTalk View SE interchangeably, but with these templates that we offer, we have some guidelines, and there's a guideline document that I'll go over in a little while. So we literally have some recommendations and tools available for a multi-monitor operator console or a single monitor console. And so what you see here, look at the multi-monitor first. You see on the top left, we have a level 1 display. And so that would be designed to always stay open so that the operator sitting at the console can always see the full overview of what he's looking at. And I'm going to try to turn on my laser pointer here. So you see that level 1 display there. So that's going to be the overview. And then if you have a 4, so this is a 4 monitor system. And notice again, also, if you have the ability to build a 4 monitor system, the top right would be your alarm summary. So you could always see the alarm summary there. Very helpful for the operator. And then notice the consistency. And then when you actually get to your troubleshooting or your daily operation, you're typically clicking and writing things into the bottom 2 displays. So that's where you get to your level 2 or 3 displays, and then that's where you then would get to your pop-ups, your faceplate pop-ups, et cetera. But notice there's all these additional headers, the 4 monitor headers, level 2, level 3 button bars. Those are pre-drawn templates. And so that's what we're looking at the bottom here. We're looking at the 4 monitor header here on the bottom left. And then over here with the alarm display, this would be part of the single monitor header. So if I look at my single monitor, I don't have the luxury of being able to put a level 1 display or an alarm summary always on. So there's a header that has, a very small but visible alarm display built into the header. So this would be something you may want to use for a single monitor system. And again, these are templates that are available to you for any FactoryTalk View SE system. Okay, so this is some examples here, and this is an example of a level 1 display. And so a couple of things jump out at me, being in the industry for a while and have a little bit of background on older HMI systems. Notice the level 1 display doesn't have any graphics on it. You don't see reactors, you don't see piping. All you see is information. So you see bar graphs up here, you see trends. And so part of the research that was done on HMI situation awareness, one of the things they came back with was putting charts and putting trends on screens provides a lot of information, more information than, say, graphics might. So on a trend, so the bottom 3 trends down here, you can look at, and maybe this is hourly, maybe this is 6 hours, depending on the process. But you can look and see how the system has been operating just by looking at the level 1 screen. So you can see dips, you can see changes that have been made without going into any kind of detail screen. Also notice we've got yellow lines and orange lines. And so those all happen to do with abnormal conditions. So we can see the reactor has got an orange square around it. Well, I know that is a higher abnormal condition than my turbine that's yellow. So at a level 1 screen, I get a lot of information without being too overly clustered or busy. So that's the purpose of a level 1 display. And so I think that's kind of interesting that you see the trends and the bar charts on a level 1 display and not really the process equipment necessarily. So that's your overview screen. Now at a level 2 display, so again, this is where the operator is going to spend majority of his or her time in normal conditions. And so you see more details here. So we're inside the reactor level 2 display. So inside the reactor, I do see about 5 different smaller parts of the reactor. I have a main reactor, I have a feed, I have a gas supply, scrubber, etc. So this would be where your routine activities would take place. So you do have maybe some critical valves and pumps here that you're looking at. And based on the colors of those, I know what state they're in. And I'll go over that a little bit later when I get to the style guide. But again, without having to look at an alarm screen, I know that my scrubber is orange over here. So I know I've got an issue here. And then I see some red up here. So I know I've got an issue here as well. So I know exactly where I need to go when I go to my level 3 display. So again, here's my main reactor. So this is a level 3 display. And so I've got a lot more details. And now here's when I see some of my equipment just to help me out and pinpoint exactly what I'm looking at. So now I see a flow transmitter. I see what looks to be maybe a control valve here. So this is where my PID details would be if I needed to go tune that. But here's my abnormal condition. So I've got maybe a temperature indicator that's a little high. So I need to take a look at that. Again, this would be my level 3 screen. And then so any deeper than this, then I'm going to start using my pop-ups. So I'm going to go into my indicator here, my temperature indicator, or maybe my PID loop here for more information. So that kind of covers the general topic of situation awareness. And so what I want to go into now is a little bit more detail on how Rockwell handles that with the HMI Graphic Framework. And so again, we talk about Plant PX here, but all these tools are available in non-plant PAX systems. But Rockwell released in a couple of versions ago, I think it was version 11 of FactoryTalk View SE, Rockwell released an ISA 101 HMI style guide. And so Rockwell calls it the process HMI style guide, but it is used in very much detail to follow an ISA 101 high performance graphic guideline. And so with the purpose of improving situation awareness for the operator, making abnormal conditions easier to troubleshoot. That's really the whole purpose of this whole HMI initiative. So turning data into information, making more easily managed security and change management and operator actions, et cetera. So what's part of the graphic framework? Well, there's 4 main components. And so, and we've talked about sort of how to level 1 through level 4 and how to organize their screens, but specifically to what you get with the HMI graphic framework, you get 4 main components. So you get a number of header graphics. So whether that would be your multi-monitor header or your single monitor header, we talked about earlier in the presentation, those headers are pre-configured graphics that you can download from the download center and import into your HMI screen to start using. There's a whole number of process control displays that also are available, and so those displays you can use to develop your system. In addition to those displays, you've got a whole series of different library graphics that are available, and all the faceplates that are available. And then within the header and footers have built-in navigation, built-in alarm indication. You have standard alarm screens Brian talked about earlier in the presentation. So this is all encompassing of the graphic framework that's available for you to use as templates. So in using this framework, you are getting more in tune with configuring an HMI screen than actually developing or writing an HMI screen. And so that in turn should reduce your overall development time using FactoryTalk View SE. So some more information about the graphic framework. Like I said, it's very flexible. It's standards based. So you have your full level 2 button bar, level 3 button bar. You have your header bar, flexible but standard. So you can change your you can take the Plant PX graphics screen off and put the end user logo on the top left, and becomes more intuitive in deploying. So you're dragging and dropping, you're configuring pre-drawn graphics, etc. So, and that in turn, should handle the standardization and ease of use of navigation of the system using this framework. That's the whole idea behind this framework. And so this is a little more detailed screen of what this may look like. So again, you've got your site overview on top, and you may have a pop-up. You may have a pop-up site overview that might jump to different level 1 screens on here. But then you have your level 1 with level 2 buttons access. So in navigation, you typically go from level to level. So you don't go from level 1 all the way down to level 4 faceplates. So you start at level 1 as your overview, and then you have level 2 displays that are open. And then for normal operation, you're going to stay in level 2. But then for abnormals or for troubleshooting, you're going to jump down to level 3 and level 4. That's typically how the HMI is going to be built, and how the framework would look like, much like this diagram here. And again, this is sort of to review, but this is another example of what the different graphics look like. So again, your level 1 overview, lots of bar graphs and trends is really pretty much what you're going to see in level 1. And then the breadcrumb alarms, basically highlighting the red, yellow, orange, what have you, of different priority abnormalities to chase down. And then level 2, you have your main control, and this level 2 does have some graphics tied to it. It looks like maybe a couple of reactors or separators there. So that's your normal operation. And then you come down here to get to more your details and your detailed displays and your faceplates. So that's pretty much what covers the presentation. Now, what I'd like to do is go ahead and share my screen, and I want to go over quickly I'm going to go over this style guide document. And Brian, can you see my screen? I'm going to take that.
Yeah. Sorry, I was double muted.
Yeah, that's okay. Yeah, I'll take that as a yes. So this is a really helpful guide. So it's about 56 pages long. It's available for download on Rockwell's literature site. If you search for it, it took me search for process HMI style guide, because it doesn't, or you can just Google it and Google FactoryTalk View HMI style guide, and Google will find it. But and we can put a link to the screen, but this white paper on the presentation. But this is really a really helpful guide to step you through how to implement all these tools, all these templates that Rockwell has available. So I just want to take the time to go over a couple of things in this document, just to kind of give you a taste of what this looks like. So remember, in the presentation, I had a couple of these layouts. And so this would be a standard HMI template. So again, this is, our presentation today pulled straight out of this document of what a layout would look like, whether you have a single monitor or a multi-monitor, or 4-monitor system. And so it's kind of scrolling through here. What I wanted to show you as well are the 2 headers. So these headers are part of the library objects that you download from Rockwell's download center, and so just drag them straight into your VUSE display, and then use them and customize them as you wish. But these are all standard. So the standard headers, here are the standard button bars. So you've got level 2 and level 3 button bars. That are, again, also standard displays that you grab in, and then here's an alarm summary. So this is a standard screen display that's also available, the standard alarm summary display, and then that would be just example of showing you what the alarms look like in the display. And this white paper just kind of gives you, walks you through how to implement those. A couple other things I want to show you. So some of the dynamic process objects. So Rockwell in the library standardizes the colors and the view that you see based on the state of the object. So we'll look at valves and motors here. So a valve control, a valve can be open and closed, but can also be closing and opening. Or you could have a stopped too if you had a solenoid valve or something. But these are these kind of in between steps are sometimes as important if you're trying to diagnose an abnormal condition as the general state. And so these standard objects different colors and graphically will give you this information of where the state is of the particular device. And again, like a motor could be stopped, it could be running, but it's also could be starting, stopping, or jogging. So if you're jogging, if an operator is out there jogging a motor in the field, then it's important for the board operator to understand that. And of course, abnormal conditions. So if a device is in an abnormal condition, it'll be rectangled with an alarm around it, so you can follow that down. And this is an example of all the of different motors you can just drag and drop onto your screen. You can group motors together. So depending on how your process is working. So that's your dynamic process objects. A couple more things to show you. So a little bit about the bar graphs. So this is some more detail of what's in the bar graph. There's a lot of information on the standard bar graphs. So not only do you see your current value, but you can see the scale. You can also see the alarm points, the alarm zones. You see the user-defined name as well. And then if there is an alarm condition indication, you'll see that covering that particular bar graph. So there's a lot of built-in value here on using these standard objects, and how they follow the ISA 101 standard is pretty interesting. So a couple more. So trends. So these are the small little trends that are on the operator screens. Now, earlier in the presentation, we talked about TrendX and all the details you can get with TrendX. You can put your process values, but you can also layer alarm data and event data and asset center data, all that on top of the TrendX tool. What I'm talking about here is really just the basic trends that we put down on our layer one or a level one and 2 and 3 screens. So again, just on these little screens, you have your alarm information here. You got engineering units that auto scale. A lot of neat information on these trends to help the operator. And then finally, did want to show the alarm tab in the faceplate. So if you're down into level 4 troubleshooting, all of Rockwell's level 4 library objects support or have an alarm tab. So you can get to the alarm information directly while you're troubleshooting the device and not have to jump back to an alarm summary screen or a dedicated alarm screen. So that's important, especially if you've got a single operator monitor. And you don't want to jump in between an alarm summary screen and a troubleshooting level 4 faceplate. So this just gives you some example of what that looks like. And I think that kind of covers it as far as situation awareness and ISA 101. And again, I would highly recommend if you're looking at implementing a FactoryTalk View system, take a look at this process HMI style guide, because it is very helpful in helping you develop View SE screen applications that support high performance graphics. So I did notice there was a Q&A. I don't know if anybody wanted to grab that one. I see the question, can you explain OPC UA publish and subscribe again? The OPC unified architecture has built-in security inside of it, and so in order for communications to happen, the producer or the originator of the data has to publish it, and then someone that wants to grab the data has to subscribe to it. And so that's a interlinking communication, kind of like a signature that has to happen. But I don't really have the details on that. That might be something we would get back to you on with more information And unless you guys have anything to add to that.
No, you pretty much got it. It's you publish to what information you have, and then anybody under that umbrella essentially can subscribe to whatever information they need, or essentially not subscribe to any information that they don't need, so you don't end up cluttering essentially your bandwidth with a bunch of unnecessary information. You only get what you need.
Sounds good. So I guess if there aren't any other questions, like to thank everybody for joining us today, and look forward to having another user group next month.